Hello you absolute legends and welcome back to another video. Today we take a look at an efficient and streamlined way to create multi-material prints even without a multi-material mod on your printer. As is obvious, instead of a multi-material mod, we'd be swapping filaments by hand. Now of course, as you can tell, this is not an approach that would work where there are hundreds of filament swaps in a single print. But it can definitely work for prints with maybe under 20 swaps or so. What is more is that it would work beautifully if you want to make colored lithophane. I made a video about that and you can click on the I button to find out more. Now, I'd show you two approaches in this video, the convenient one and the manual one. They are marked clearly in the chapters below. In the convenient approach, I made a tool that converts multi-material G-code to swap G-code. Currently, it only works for the Prusa Mark III S model, but if you have any other printer, just reach out to me in the comments and I'd get it working for yours, no problem. At the end of this video, as usual, there would be some helpful and wholesome comments from my previous videos. And with that, let's get started. So let's take a look at the convenient approach. For this, you're going to need the Prusa Slicer application. I've made a printer profile specially for the Prusa Slicer application. The link would be in the description below. It looks something like this. It would be a config.ini file. So to import it, just go to File, Import config, and then choose your particular file config.ini and open. With that, you'd get a new printer profile. Go to printer settings. It says something, the name of the printer, and then modified in parentheses. So just go ahead and save it so that it doesn't get wiped when you restart the slicer. Just name it swap. I'm gonna name it swap. Okay. So now you have a new printer profile in your slicer, and now you can start importing different objects, and then we can convert it into a multi-material code, into a swappable code. So I have chosen this STL of a Raspberry Pi case that I found on Thingiverse. The link to this would also be in the description, and I found some really good STLs. So this is the STL for the top. So this is color 1, color 2 and color 3. So this particular top has 3 parts and I liked it for printing, so I'm gonna import these 3 into my Prusa slicer. If you did the printer part right and the correct printer is selected, it would automatically detect that it's a multi-part object. So just click yes here and it would import it as a multi-part object. So as you can see here, it has 3 colors. You can choose which filaments you want to print it with here and here. So you can decide the profiles here. You can add up to 5 different filaments, and then you can choose if you want to print it with the first one, the second, or the third one. Coincidentally, everything is right for me. I'm gonna print it in cyan, white and magenta, and the profiles are all right. Let's get a top as well for our case. So I really liked this one, the hex design. I'll import this and color 2. Again, it would say multi-part object detected. Click yes. So this thing here is a wipe tar. We'd get rid of it because we don't need it in our approach, but we need it to check the number of tool changes. If I slice it now, it would show me the number of tool changes. But if I get rid of the wipe tower and I slice it, it would not show me the number of tool changes. I don't know why that is. So slice it. Tool changes basically mean how many times we would have to swap the filament. So right here it shows us the number of tool changes would be 7, which is a pretty reasonable number to be swapping by hand. So this print works out perfect for us, and the final print would look something like this. Now let's just go to print settings and go to multiple extruders, disable the wipe tar. I'd give you another tip for skirt and brim. Keep the number of loops to 1 and skirt height to 1 as well. In my experience, I've seen that skirts cause more problems than they solve. that sounds wrong. So anyway, we got rid of the wipe tower. Let's go back. Let's click arrange once more. I like this better. Slice now. And we are done with the slicing. Just export G-code. So currently this is sliced for a Prusa Mark III S with an MMU2S attachment. So if you're watching this video, you probably don't have an MMU2S. So we are going to post process this and convert this into a G-code that we can swap by hand. For that, I've made a very simple tool in HTML. So this tool would be available to you as a website. Link would be in the description. And I'd show you how it works a little bit. So here you can give different names to your filaments, which by default are 0 to 4. We have 5 different filaments. But I'm going to name my first filament cyan, the next one would be white, and the next one after that would be magenta. This right here is the X and Y position of where the extruder should be when you're trying to swap this filament in. This would come into play in just a few minutes, and you see there if you don't understand it right now, so don't worry too much about it. This name would be displayed on the screen after you swap something. So let's say I just inserted my white filament into my extruder. If my next filament is going to be cyan, it would say cyan on the status message line of my LCD screen on my printer. So that makes it very convenient for me to remember which color I'm going to swap in next, right? So after that, upload your file, your G-code file that you just exported, which is this one. Open. So here it would ask you to download this file. It has processed the file. Now you can download it. I would like to stress one part. None of this is server-side code. It's all running on your computer. So if you have some file, some G-code that is private or something, you can still use it because none of it is going anywhere outside your computer. It's all working on your computer. If you are still worried about it, you can open the website, you can go offline, and it would still work. So all the processing happens on your machine and none of it is server-side code. So by default the name is processed. Let's name it Raspberry Pi case and save it. After that, you can take this G-code, you can transfer it to your printer by whatever means you prefer. I use an Octoprint server on my Raspberry Pi. Before we start the print, I would like to be very clear about the fact that this tool is provided without any warranties or any guarantees. While it's very unlikely that you'd end up with G-code that might damage your printer, it's not completely impossible. So only use this tool if you do know what you're doing. And another thing I would like to mention is that please do not leave your printer unattended when you're using G-code that has been processed by my tool. So here we start the print without any filament in the extruder. Please remember, you don't have to put any filament in the extruder itself right now to start the print. I started it off screen using an app called Printoid on my phone through my Octoprint server. So it would give you a warning that this G-code has been sliced for a different printer. Now I could have gotten rid of this warning in many different ways, but I did not because I cannot stress this enough. I need you to remember that this G-code has been processed and edited by another tool, and please do not leave your printer unattended. After the bed heating is done and your printer has calibrated itself, it would tell you the filament that you need to swap in. Here you can see it's cyan. So this message would go away as soon as the printer gets into a, let's say, the swap state, where you can remove the old filament and insert the new filament. The thing you need to remember here is that even if you miss the message or for whatever reason you forget which was the next filament, the position of your extruder can tell you which filament you have to put in. So right now the extruder is at the bottom left corner, which is 0, 0, which means cyan. We set this in the tool earlier. So I'm just going to insert the cyan filament right now and start the print. As you can see, the message on the LCD screen after you swapped the cyan filament changed to white. This means the next filament on the list is white. So when the printer stops now for a swap, you have to insert white. And this time it won't go to the bottom left corner, it would go to the bottom right corner, which is at 2550 or 250, I forgot. So that way, even if you forget that it was the white filament that you had to insert, you would know by the X and Y position of your extruder which filament you need to insert. So that is how this print is going to work. And after 7 swaps, the message line would not show a color anymore. That means the number of swaps is done, and now the same filament that is in the extruder would finish the rest of the print. If you're enjoying this video, please don't forget to hit the like button and the subscribe button. It helps me out a lot and you won't miss any of my future videos. Before we move on to the next approach, let's take a look at how a typical multi-material setup works. Here we have our printer, and this is our MMU unit. As we know, any action on a 3D printer corresponds to a G-code. I made a video explaining G-codes. Click on the I button to find out more. Anyhow, the G-code for filament change looks something like this, where T is the command and 0 is the filament number. Whenever the printer encounters this type of G-code, let's say T3, the printer would interpret it and send a signal to the MMU unit to unload the current filament and load the filament specified by the command. What my tool does is that it locates all these G-code commands and converts them to filament swap G-code commands. It also adds a few message lines to guide which filament goes next. Now for the manual approach. For this approach as well, most things do not change. You start by importing the configuration file, config.ini. The link would be in the description, as I already told you. You go to the printer settings, you save it by whatever name you want, and then again we come back to our print. Go to print settings, multiple extruders, disable the wipe tower. So to be honest, you can keep the wipe tower if you want to. It's not a huge problem, but it doesn't make any sense to waste more filament than you need to. So for the manual approach, you'd go into the custom G-code section. Here it asks you for tool chain G-code. If you just put M600 here, it would convert your G-code into swappable G-code, because M600 is the filament swap command. The problems here being, it would not tell you which filament you have to insert into it. So you would lose that capability. It won't show you the message on the screen. It won't go to the particular corner that you have decided for that particular filament when you're swapping it. Another problem being that this does not remove the MMU specific code from your G-code. So if I slice it right now, I export it, you would then have to open it in a text editor. I am using Sublime. You'd have to find all the G-codes that look something like this. So you'd have to remove all the G-code in it that says T0, T1 or something like that. So you'd have to look for everywhere it says M600 and then remove the next line. It says T0. This is basically a command for the MMU, which tells the MMU to load the 0th filament. So we remove this, then you go to the next one, you remove this. So you'd manually have to remove all those references, and I would not really recommend this approach, because first thing, you won't know which filament to swap into your extruder. It would work if you have only 2 filaments that you want to print with. If it's only a 2 filament print, this can work. And this is easier, and this is something you're doing yourself. There is no tool involved, there is no problem of bugs, or there can be no bugs. So if you do decide to do it this way, I have shown you how to do it, but I have shown you the convenient way as well. Now, on to some wholesome and helpful comments from my previous videos, both on YouTube and Reddit. Not all wholesome comments need to be praised, as I have mentioned before, and keeping that in mind, here is one from Tyler124352. He says, learn why in the comments, then you fail to explain why yourself as the title implies, and instead try to sell us your YouTube channel. I would be very honest with you, as a content creator, my posts have to ride a razor thin line between catchy and clickbait. And last time I might have erred a bit on the side of clickbait. I would try to keep better judgment in the future. Daniel Seguin says, your voice is mad relaxing, just watch this at 2 a.m. Thanks a lot, Daniel. The Root Beer is Lifeman says, wow, there's a crossover I thought I'd never see. I do psychology professionally and 3D printing casually. Definitely will check this out later. I hope you did check it out later. The Root Beer is Lifeman, and I hope you liked it. And that brings us to the end of this video. If you liked it, you know what to do. If you didn't, the other one is fine. If you have any critiques or inputs, please leave them in the comment section down below. I read them and they help me a lot. For more original and innovative content, hit the subscribe button. And until next time, just keep building.